Hey y'all, my name is Jessica Moon. I live in Huntsville, Alabama, and making dashboards in Tableau is a big part of the role I'm working in. I do Tableau for work and for fun. I guess to elaborate on the fun aspect a bit, I post projects to Tableau Public for a number of reasons. It's a creative outlet. It allows me to do some critical thinking, scratching an itch that perhaps a crossword or Sudoku might for others. And it's where I keep examples of various novel techniques, so I have an example handy when I have a work need. I'm going to give a little presentation about how I'm using Python to pull data sets for fun projects I post to Tableau Public. Keep in mind, I'm not a Python expert, more of a hobbyist. I typically use two libraries to do web scraping, Beautiful Soup and Selenium. I'm going to go over programs I wrote to get the data for the two Vizzes you see here, so you'll have a taste for both libraries. Next slide. Okay, so the purpose of writing these programs is to really cut back on the manual effort in obtaining data and transforming it. I'm a mother of three, and I don't have time to copy and paste from a website, nor enter 100 different search terms and download a couple files each. Python can reduce a several-hour effort to maybe an hour or less, depending. I've linked some great videos and tutorials you should check out when you have a chance. The first Viz we will discuss is one that takes the Diversity in Data, which is a great community project data set, and enters those women in Google Trends. The regional and weekly interest data CSVs are then downloaded. The second program takes those downloaded files and creates two CSV outputs, regional and weekly, in the tabular format that works with Tableau. So we take 200 files and consolidate to two. You can see in the little callout that the first program is basically a bot. Selenium is considered a testing library because it can act like a user, typing, clicking, etc., but it can also be used for scraping implications. It's a bit of a pain to get the libraries and driver downloaded, but well worth it. The 3 video links on the previous slide are really enough to become dangerous in it. We'll peek at these programs after we look at this next Viz. The second Viz is on Power Rangers, a show from my youth in response to a DataFamCon, which is another great community project, prompt. In the first program, we use Beautiful Soup, Pandas, and a couple other libraries to visit IMDb for each of the original actors and pull their acting credits, title and year as highlighted to the right. The second program takes the first program's output and rearranges it in the JSON format needed for Tristan Guilevin's network generator. Oh, and for background here, Tristan is a Tableau visionary who has created several cool free generators. Let's take a peek at his site, where you can generate a network, Sankey, bump chart, eSwarm, Veroni, or Chord. It's really incredible the power these generators have. So I highly recommend you check it out. All right, let's take a quick look at these programs. All right. First up is the Selenium program for the 100 Women on the Web Viz. First, we bring in the packages we need for the program, like Selenium's WebDriver, Buy, and Keys. Time allows for us to add pauses, which are uber important so we don't get blocked from the site. Pandas helps us bring in the Excel file as a data frame. Here we're getting the data set and then creating a list from the name column. I've designated the XPath for 3 different places that the program needs to find to type in the search term, download the data for both the trends and the region. How do you get XPath? Well, you visit the program you want to interact with, find the element of interest, right-click, inspect. It's then highlighted in blue in the designer window. You go to copy and then copy XPath. Here I've designated a sleep time of 5 seconds. Sleep is very important both in life and in your scraping program. You want the program to act like a focused user and not something attacking the website. So scrolling down here, I am looping through the names that I pulled in this list, and I go to the website. I click refresh, which you might understand why I did that when we run it here in a second. And then I go to the search bar. I enter in the name. There's a little cleaning here because I noticed some extra spaces. Click enter to generate the trend data, making sure to add pauses, and then download the trend and the map data. Let's take a quick look at this in action. So here it is. Let me pull it up here. See, it first starts out saying that's an error. But then the refresh handles that. Types in the search term. And one time I click Save File and do this automatically from now on. And now the action is actually happening in my Downloads folder, where it's taking the files and it's downloading them. So at the end of this program, I have 200 files, 100 map files and 100 trend files. And let's stop this real quick because it does take a little over an hour to run. When I did this officially for the Viz, I set it off, clicked to download the files, and then got Mexican food. So it's nice not to have to babysit. All right. After all 200 files were downloaded, I copied and I pasted them into a separate file folder, which is referenced over here. I created empty lists for the map and the trend, and then I iterated over the folder and read the CSV. And this parse column was a little tricky. I think I had to Google for this part, but I do have an example down here for one of the files. You can see that for one of the files, the very first row is the column headers, and then the data follows. So that first column, I want to get the search person. So I split on the column, on the comma, and I take a index of 1 because I want the second part of the split. In Python, 0 is the first, 1 is the second. So for the very first item, index of 0, I split on the comma. I take the first part of that split, then I colon and take the first part of that. Then I look at the file name itself so I know where I want to put the data. If maps in the file name, then I know that for a row, if I split on the comma and take the first part of the split, that's country, and I add country. I go ahead and add names, so the list will be the same length, and I've got the searches. I do something similar for the trend. I send it to separate lists. And then I use pandas to create the data frames where the equal length lists are side by side. It's sent to a CSV, which got used in the Viz, both CSVs did. So take a quick look over here. This was the result. In this Viz, I kind of used it as a use case to get better familiar with dynamic zone visibility. I wanted it to only expand one section at a time. It's been a while since I'd opened this up. Like so, and also there's actions off of women up here, highlight action. This is available on my Tableau public if you'd like to dissect. Really love dynamic zone visibility. Next up, we have the Power Ranger scrape. In this case, I used Beautiful Soup to do the scraping. I created a quick data set looking at the original Rangers for each color, their character name, IMDb link, Ranger color, you know, just a small like 6-row Excel sheet. I create my empty list that I'll need for the data frame. And then this time I'm iterating over the entire data frame. So I can repeat those attributes, put them in new lists, so everything stays together. Before we look more into this, we'll take a look at the soup. If you looked at the original slide, I had Amy Jo Johnson's credits up, and this is the soup for Amy Jo Johnson. And let's see if I can find the has-been, which was, this was the top credit that was on the IMDb site. And I kind of inspect the HTML tags and classes around, and I came to decide, well, I think to get both the year and the title, what I want to iterate through is film a row odd and film a row even. But as I search, film a row odd. You can see that the ID will go from actress, director, to producer. And I'm really only interested in the acting credits. But you can see with each ID, there's actually a unique string following it, so I can't call the ID outright. So I asked ChatGPT. I just wanted the ID to start with actress or actor, and this is what ChatGPT gave me, and it worked. Then in each of those blocks, I go through, I get the year, get the actor link, repeat some of the attributes that were in the data frame to create the final data frame that gets sent to CSV. Alrighty, and then after I did that, I wanted it to be in a format that would work with Tristan's network generator. If we look over here and take a peek at the question mark here, this is the JSON format required. And when I looked at this, I thought this looks an awful lot like a nested dictionary. I wonder if a dictionary could be created to a JSON, and Google said yes, so here I am. I go through that Power Rangers file and say the to node is the credit link, the fro node is actor, and then I created these lists up here, and for each to and fro node, I look against this unique node list to see if it's already there, because the nodes portion should only be the unique actors and titles. And if it's not, it gets added there. I create a dictionary here that gets appended to the node list. And then for every line in the data source, there's this source and target node that gets appended to the link list. I compile all of that, send it to a JSON, and that is what I have over here. This is the Power Rangers file already loaded. There is a way to get to that JSON using Tableau and a text editor. That's available in this YouTube tutorial. Also in the tutorial is how to use all these sliders to change the shape and sizing appropriately to your needs. So I recommend checking that out. But for the sake of the demo, to get into Tableau, I'll just mention I used the CSV output option here. All right, so here is the Viz. First, let's take, come on, a look at the data. All right, if you were to have downloaded a Tableau public or desktop file, you would see the way that Tristan handles the data is to use the dreaded noodle. I'm not a noodle person, and I need to read more and really noodle the noodle. But in my current project, we use Alteryx to do the integration and shaping. And in previous projects, it was SQL. So what I understand is joins. This first join is to a file called network. And upon inspection, it's just a path with a value. Looking at the join, 1 equals 1, this essentially doubles the data set. So we have 2 points for a line. All right, I brought in the nodes CSV from Tristan's output. And the first join, I do actor equals ID. I then went to the XY fields and called them from X and from Y. I do one more join to it where credit link equals ID, and that became 2X and 2Y. Now we'll take a look at the dashboard, go into the main sheet. This was done in map layers, which are really the best thing since sliced bread, because you can stack multiple things, and it's just really powerful. What's important to note in map layers is that the order of your layers matters, and the things that are arranged higher in the order come to the forefront. So if I take this actor node shape layer and move it up, the shapes are now in front of the pie charts. Let's see if we can recreate this real quick. All right. The MVP calc in this dashboard is final node, showed up here. And we look at that path and we say when it's 1, I want to consider the actor points, the from fro X, fro Y, and else the 2X and 2Y. And you might notice that it's divided by 100. When I was originally making this viz, I was very puzzled why nothing showed up on my screen. And doing an inspect of these XY coordinates, I discovered that they were outside of the latitude and longitude bounds, but dividing by 100, it's all good. Now I'm going to need these for both the lines and the nodes, so I'm going to bring it in twice. I prefer to work X comma Y, so after I get 2 layers, I click swap rows and columns. Now what's important is what's on detail, and I will have to put ID, both types of IDs, on each layer. And that's still not quite enough because what it's doing right now is splitting the difference between the actor and the title points. So I will need a path as a dimension. This will become a line. Here, we'll put path as dimension. And for the nodes, I have those as pies. Some of y'all might know I'm pro pi. I hear it's rounder than Tableau's circle mark, and I wanted to show, better show the titles that the Rangers shared. So I take Ranger and put that on color here. Also, I wanted to have the pictures for the actors, so I did an actor node calc where it just regards a path of 1 and then that previous calc we did. Let's add actor node. And we just need to put actor there. Let's change the shape. We'll put Ranger. Since I've done this all before, it's just reassigning what I've done previously. A little bit bigger. Also, I wanted to draw more attention to the Power Ranger titles versus other titles. So for Power Ranger nodes, I said if the title contains Power Ranger and the path is 2, look at final node. Power Ranger nodes in. Let's add the ID detail. Make it a pie, a little bit larger than the previous ones. Put Ranger on, color, and also give it a little outline. Oh, I think the axis should be reversed. And I wanted to draw attention to how much of the actor's career was Power Ranger based. So I have 2 calcs, Power Ranger titles, which looks to see if it contains Power Ranger, and then other titles that finds the remaining credits for the actor. And I bring in actor node once again. Actor has to be on detail. It's a pie. Try to make it about the same size. About. Put measure values on angle. Measure names on color. Change it to just Power Rangers and other titles. And because what I was most interested in was the proportion of Power Rangers, I want that at 12 o'clock. So let me do a sort. So it's arranged at the top. I did a red outline because it was kind of similar to the Power Ranger belt. Reduced the opacity. And then the final thing, if I leave you with only one thing, I saw this in another tug. I'm going to put over here on this one, actor onto label. You can see that some of these are almost impossible to read, but you, see if I can get to it. You're not going to do it for me today, are you? Sorry, technical difficulties. You can actually grab the label and move it, which was pretty big for me. So there. This concludes my presentation.